Number 31. What is the equilibrium expression for this reaction? We are writing the KEQ, and in the mass action formula, we are not supposed to include the liquid and solid. Therefore, the only concentration that's going to be relevant is oxygen. Answer is D. Number 32. Okay. For the reaction, for the exothermic reaction, if it says exothermic reaction, the heat must be released on our product side, which change will increase the quantity of nitrogen dioxide in the mixture. So we want to increase the concentration of nitrogen dioxide, then we definitely favor the forward reaction. So choose any choice that favors forward reaction. You need to understand the Le Chatelier's principle. And we're going to tackle one by one by these A through D's disturbance of the equilibrium. We're going to increase the temperature in A. When you increase heat, imagine as if the heat is as if the compound. When you add more heat or when you increase temperature, we would expect a reverse reaction. Okay, it wanna lessen the tension on our product side by forming the reactant. And in our B, decreasing the container volume. This really depends on the number of gas moles. So on the left side, the reactant side, I have 11 moles of gas. On the product side, I have 10 moles of gas. And I'm decreasing the volume. It's as if in the same size room, we have room A and room B, which have the same size. And imagine in the room A, we have 11 people, and in the room B, we have 10 people. Imagine we're decreasing the room size proportionally for both rooms. And we would expect more crowdedness in 11 people room, right? Compared to the 10 people. So we wanna release the pressure or tension, so the forward reaction is favored. Therefore, answer is B. In case you're wondering about C and D, neon does not affect our Le Chatelier's principle. Neon is not to be found in both reactant side and the product side, so C is out. And for our D, the adding water vapor, when you add more water vapor, we want to release the tension by favoring the reverse reaction. So D is also favoring reverse. 33. Weak acids include which of the following? I only see the hydroiodic acid. This is the only strong acid I see. You need to memorize 6 different strong acid and 9 different strong bases. And hydroiodic acid is one of them. Now the tricky part is the nitrous acid in Roman numeral 3. We know the nitric acid is strong acid, however the nitrous acid is not. Meaning when you put this in water, it's not going to completely dissociate and favor the forward reaction. So answer is 1 and 3. In other words, they form the equilibrium sign, meaning reverse reaction can happen, and it doesn't completely favor the forward reaction, just like what we see in the hydroiodic acid. As opposed to this, it has single arrow. Therefore, answer is D. Okay, 34. We have two equations that acid and base reaction. According to the equations above, what is the conjugate base of bicarbonate ion? Okay, we first need to identify what are the acid and base, okay, and also identify the conjugate acid and base. So looking at our first equation, I see this being our acid. Why? Because acid always wanna donate the proton ion, which we see here, and base always wanna accept or receive the proton ion from acid, and that's what we see on the product side. See, water receives the hydrogen ion, therefore we have acid and base. Now the bicarbonate ion, when it tries to go to the reverse reaction, now this is what we call conjugate, and it wanna receive the hydrogen from the hydronium ion. So this is a conjugate base, and this obviously is a conjugate acid. On our second equation, the water acts as if, again, the base, because it wanna receive the hydrogen ion from our bicarbonate ion, and bicarbonate ion wanna donate the hydrogen ion to water. So now we have conjugate base and conjugate acid. Looking at the equations, we want to find the conjugate base of bicarbonate ion. Well, we just found this, right? That's our conjugate base of our acid, bicarbonate ion. Therefore, the answer must be D. Number 35, saturated solution of which salt will have the highest concentration of silver ion? Okay, it's saturated, meaning we have the maximum dissolved ions in our solution. And to do that, we need to use the solubility product calculation. Okay, to illustrate A, we have silver chloride. Okay, initially the silver ion and chloride ion is 0. However, as time goes on, as the equilibrium is reached, we have certain solubility here. Okay, it's a 1-to-1 ratio, that's why I'm putting the S. You could use X if you want, it really doesn't matter. This is a solid, silver chloride is solid, so this is not part of our mass action formula in the equilibrium constant. Oh, it's not equilibrium, actually it is equilibrium. Equilibrium constant is more general term, but for our specific purpose, it has to be solubility constant. Okay, so we have S squared, and that's equal to 1.8 times 10 to the negative 10th according to our given, and we have to find S. Okay, if you find that, let's see what I got. Okay, you just have to square root both sides, by the way, to find S, and you should be able to get 1.34 times 10 to the negative 5th. Alright, so moving to B, so that was A, now we're gonna do B. This time we have 2 ions of silver cation, and then we have chromate ion, just one of them. And if I'm to write the equation again, alright, we have a change of plus 2s due to the stoichiometry, and plus s. In the KSP equation, we have 2s squared and then s. That's equal to 1.1 times 10 to the negative 12. Okay. Then when you square the 2s, you get 4s squared times s, you get 4s cubed equals 1.1 times 10 to the negative 12. That eventually set s equals to, let's see what I got. So to perform this, you just have to divide it both sides by 4 and then make sure you cube root on both sides. Okay, then you get to find the s, and that's 6.5 times 10 to the negative fifth. Alright, but you have 2 times of that, so you can form, in our equilibrium, you can form as much as 1.3 times 10 to the negative fourth. So moving to C. Okay, this time we have 3 silver ion. Oh. Okay. And then we have a 1 phosphate ion. Okay, we're gonna form plus 3s and then 1s. In the KSP formula, 3s is being cubed and then we have an s, so that becomes that will be 27. 27s to the 4th power equals to this value. When you get for the s, you get 1.6 times to the negative 10 to the negative fifth. Now you can do the same thing for D, but we have really tiny KSP, and the formula is same as the way we did in part B, the choice B. Because we have 2 silver ion and 1 sulfur ion, we are expected to have 2s and then the s, and you're gonna get 4s cubed on the left side equals to that. Because KSP is so small, we expect the solubility concentration to be small as well, so we can eliminate it right away. And seeing this, okay, if you multiply this by 3, it's still not gonna be as much as 2 times the silver chromate, and silver chromate is already dominating in terms of the S here, and silver chloride is definitely the smallest out of these, and we cannot even multiply because it has only 1 mole of silver chloride. So A is out, and definitely B is the answer. So in the saturated solution, the highest silver ion you can form is B.